Here are the sample problems for Math 117, Class 24. The point of these is that there's really nothing special about stock pricing. Given any martingale, you can invent options, figure out the fair price for these options, and design hedging strategies related to them. So here's the first problem. Casanova, famous gambler, is in a casino where there's no zero on the roulette wheel, so that roulette is a fair game. He comes into the casino and starts out with 2 chips. And his strategy is that he's going to play by betting on red all the time until he either ends up with 5 chips, in which case he exits a winner, or he ends up with 0 chips, in which case he exits a loser. And the casino owner is a little worried about this, so he wants to buy a call option. And the deal with the call option is it has sort of a strike price of 3 chips. It will give him the right to buy Casanova's stack of chips for 3 chips just before Casanova cashes in and exits the casino. Of course, this option will only be worth executing if Casanova is a winner and is about to cash in a stack of 5 chips. So we want to figure out the fair price of this option. And the key to figuring out the fair price is that in a fair casino, the value of Casanova's stack of chips is a martingale. It starts out at 2, and when he finally exits, that's the random variable x infinity, where he either has 5 chips or he has no chips, the expectation of x infinity also has to equal 2, because a necessary condition for any martingale is that the expectation of the sequence of random variables stays constant. So he's either got 5 chips or he's got no chips. The expectation is 2, and therefore the probability that he will have 5 chips is going to have to equal 2/5. And the value of the option is the probability that it's worth exercising, which is 2/5, times the value of the option in that case. And since it lets you buy Casanova's stack of 5 chips for only 3 chips, it gains you 2 chips, and therefore the value of this option is 4/5. Okay, so you've sold this option to the owner, and you are now feeling a bit uncertain. You say, I collected 4/5 from the owner by selling this, and I'd like to arrange things so that I'm going to pay out 4/5 no matter what Casanova does. So we're going to pay out 4/5 in either case. Well, there are 2 possibilities. Either Casanova goes broke, in which case you're willing to pay out 4/5, and the way you're going to do this is by losing 4/5 by betting, or Casanova ends up with 5 chips, in which case you want to win 6/5, so that with the 6/5 you win combined with the 4/5 that you got by selling the option, that gives you 2 chips. That's just enough to buy Casanova's stack of 5 chips, sell it to the casino owner for 3 chips, and come out even. How do you do this? Easy. You just bet 2/5 of what Casanova bets. If he bets 5 chips, you bet 2 chips. That means that either he ends up with 5 chips, starting with 2. He gained 3 chips. You bet 2/5 as much. You win 6/5. Or he started with 2 chips, went broke. He lost 2 chips. You bet 2/5 of what he bet, and you lose 4/5. Now, you could wait until Casanova has played the first round, at which case he either has 3 chips or 1 chip. If he wins, so that he has 3 chips, then the situation is very similar, except now the probability that he will end up with 5 chips has to be 3/5 in order to make the expectation constant. And what you do is bet 3/5 of his bet. Or he might lose on the first round. Now he's only got 1 chip. The probability that he will leave a winner is only 1/5. And what you do is bet 1/5 of his bet. And there's a complication here which I haven't fully figured out. With hedging for stock options, you always keep adjusting your underlying portfolio. Here, as in Part B, you can say, you just make up your mind, you're going to bet 2/5 of what he bets no matter what, and you will come out fine. Part C, on the other hand, suggests an alternate strategy where you can adjust your betting depending on how Casanova is doing. And it looks to me as though both these strategies are equivalent, but I can't see the analog in stock market option pricing to case B. Okay, let's go along to the next problem. This is Demoivre's martingale revisited, but I've invented a casino gambling situation where it is actually the right thing to do. So, here's the setup. Again, Casanova is going to leave when he has either 0 chips or 5 chips. In this case, he starts out with 3 chips, but now the rules are rather strange. He always bets on the event that the number that comes up on the roulette wheel is divisible by 3. This is an event with probability 1/3. And this looks like a very unfair casino because he either gains a chip or loses a chip. How are we going to make this fair? The answer is we decree that when you cash in a stack of K chips, you get 2 to the K dollars. So basically, adding 1 chip doubles the value of your stack, while losing 1 chip halves the value of your stack. Okay, let's prove that this is a martingale. At some point in the game, Casanova has a stack of K chips, which is worth 2 to the K dollars. What's going to happen after the next spin? He will either have K plus 1 with a probability of 1/3, or he will have a stack of k minus 1 chips with a probability of 1 minus p, which is equal to 2/3. So the expected value of this stack is 1/3 times 2 to the k plus 1 plus 2/3 times 2 to the k minus 1. You've seen this computation before. I factor out a 2 to the k. I get 2 to the k times 2/3 plus 2/3 times 1/2, or 2 to the k, and we've shown that we've got a martingale. Okay, now let's invent a call option in this case. We're going to set the strike price at a stack of 2 chips, and this option will say, just before Casanova cashes out, this option lets you take your stack of 2 chips and trade it for his stack. Of course, you will only want to exercise this option if Casanova is leaving with a stack of 5 chips. So, his initial stack is worth 8, but his final stack is worth either 2 to the 5th, which is 32, or 2 to the 0, which is equal 1. The curious feature of this casino is even if you leave broke, you can say, I'm trading in my stack of 0 chips, and they say, here's $1 for it. And we've shown now that this process is a martingale, so we can calculate the probability P that he leaves a winner by saying that that probability times the amount he gets when he cashes in his winning stack of 5 chips plus 1 minus P times the paltry amount he gets if he cashes in his 0 chips must be equal to the value of his initial stack of 3 chips, which is 8. In other words, 31P is equal to 7, and the probability that he leaves a winner must be 7/31. Interestingly, we have managed to figure out the probability of leaving a winner in this unsymmetric martingale, where the probability of going up is 1/3, the probability of going down is 2/3. Now let's figure out the option. You bought this option, and what does it let you do? Well, if you exercise it, it lets you trade 2 chips worth 2 squared, or 4, for 5 chips worth 32. So the value is the probability that you will exercise this option. We just worked out that 7/31 times the amount you get if you exercise it. This is just like paying the strike price and getting a valuable share of stock. 32 minus 4. So the answer is 7 times 28/31, and we are done.